Here are the notes for 2.2 Day 1. We are going to evaluate polynomial functions. Now before we can evaluate, we have to define what a polynomial is and then identify the degree. Once we've done that, then we're going to evaluate polynomial functions using direct and synthetic substitution. Now let's go ahead and talk about what is a polynomial function. Well, a polynomial function is in the form of y equals a sub n times x to the n plus a sub 0. So what do all these letters really mean? Well, a sub n represents your coefficient. That is the value or the number in front of the variable. X to the n power just represents your variable, and then you can have it to any power. It can be to the second, to the third, fourth, fifth, etc. Anything is in between, that's basically from between the biggest power and your constant. A sub 0 represents that constant term, so that one does not have a variable attached to it. Now to identify that a function is a polynomial, we have to kind of do a little bit of a checklist here. So a sub n will not equal 0. That means your coefficient on that first variable will not equal 0. Exponents have to be whole numbers. So every single time you see any exponents, they have to be a positive value, and they can't be fractions or they can't be decimals. So they're going to be 1, 2, 3, 4, and etc. Okay. So as I said before, it's basically the positive side of your integers. And lastly, coefficients have to be real numbers. So remember, coefficients are the numbers in front of the variables, and they have to be real. Real consists of rational or irrational integers and whole numbers. Now, if you see any imaginary numbers in front of your variables, that means the function is not a polynomial. So as I said before, a sub n is what we call the leading coefficient. So that's the very first number of our first variable. A sub 0 is our constant term, so that one does not have a variable attached to it. And n represents the degree. So you can have a degree of 1. That would represent a linear. Degree of 2. That's quadratic. 3, 4, 5, etc. Okay. Now let's talk about standard form. So a standard form of a polynomial function is basically terms that are written in descending order of exponents from left to right. Basically what this is saying that is we write from the biggest exponent all the way to the smallest. Okay, so let's talk about the type of polynomial functions. So I would suggest for this that you pause the video and try to write all this information down, and then play the video again so then I can explain everything to you. Okay, hopefully you paused the video, got this information down. So let's talk about degrees. So remember, degree is your n value. So if our degree is 0, that is what we call a constant function. Okay, so basically a sub 0, as we said before, and that's how we write it in standard form. So that is just any number you get. So it could be a fraction, a decimal, can be an integer, anything like that. Now, if we have a degree of 1, this is what we call linear. So you learned that from a long time ago. Okay, so that means on our x, that degree or the n value is just 1. So for example, we have 5x minus 7. That is a linear function, okay, of degree 1. Now, last unit, we talked about quadratics. That's when our degree is 2. Okay, so that means our biggest exponent is 2. An example would be 2x squared plus x minus 9. Now, if we have a degree of 3, we call this a cubic function. So that means the biggest degree of that function is going to be a 3. So for example, we have x cubed minus x squared plus 3x. Next, we have a degree of 4. We call this a quartic function. Okay, that means the largest exponent is 4. So examples, x to the 4th plus 2x minus 1. Now I'm going to add something to this. What if our degree is 5? We actually call this a quintic function. And really all that means is that the largest degree is going to be 5. Now, all these type of functions are still polynomials. Basically, polynomials is just that, once again, talking about it that you have whole numbers as your exponents and that the coefficients in front of your variables are real numbers. Okay, so constant, linear, quadratic, cubic, quartic, quintic, and you can kind of go to the 6th, 7th, 8th, whatever powers, all those are considered polynomials. So let's go ahead, let's get into our first example where we're going to decide if the function is a polynomial, and if it's so, write it in standard form. Now we're going to add stuff to this. We're also going to write the degree, the type, and then we're going to figure out the leading coefficient as well. So let's go ahead, we're going to do both a and b together. Okay, so let's look at a. We have h of x equals x to the 4th minus 1/4 x squared plus 3. Now remember, we're going to create a checklist to figure out if this function is a polynomial. So first thing is that our a sub n, that's our basically leading coefficient, cannot equal 0. Well, notice that our biggest exponent is 4. Okay, so this would be our leading coefficient. Well, it's not 0, so that works. Now we have to check if our exponents are whole numbers. Well, one of our exponents is a 4. That is considered a whole number. And our other exponent is a 2. That is also a whole number. So that checks off. Our last thing is we have to make sure that the coefficients are real numbers. Remember, that's all the numbers in front of our variables. Now, the number in front of our x to the 4th is just a 1. Well, we know 1, that is a real number. Okay, let's go to negative 1/4. Well, that is also a real number. So because our coefficients are real numbers, that also checks off. Because everything has been checked off and everything works, that means this function is a polynomial. So we're just going to say yes, saying that it is. Okay. So since it is a polynomial, we need to write it in standard form. Remember, standard form is going from the biggest exponent, okay, and then descending from there. Well, here our biggest is first, so it looks like we have h of x equals x to the 4th. Then we write the next biggest exponent, which would be negative 1/4 x squared. So minus 1/4 x squared. And then our last thing is our constant here. We have a plus 3. So in this case, our function was already written in standard form, but I wanted to talk about how you would write that. Okay, now our last thing that we're going to do is figure out the degree. Degree is what we're talking about, the largest exponent. So we look the largest exponent, and we're going to go off of our standard form to notice this. It's going to be the 4. So our degree is of 4 because that's our largest exponent. And then we're going to write the type. So you kind of look back from our last slide. We go to degree 4, and the type they tell us is quartic. So this is a quartic function. And our last thing is we got to figure out what is our leading coefficient. So I'm going to use LC for that. So leading coefficient is the number in front of our first term here. So our first term in our standard form is x to the 4th. And so the leading coefficient, or the coefficient in this case in front of it, is going to be 1. So that's what our leading coefficient is going to be. Okay, let's go ahead and try B now. So we have g of x equals 7x minus square root of 3 plus pi x squared. Okay, first thing, we got to make sure that our exponents, they're basically whole numbers. Well, here's an exponent of 2. 2 is a whole number. Now notice for the 7x, well, that exponent is just 1. Well, 1 is a whole number, so that works out. And negative square root of 3, that's just a constant, so we don't need to worry about it. So that checks off. Now we have to figure out if the coefficients are real. So we look at our first one, 7, well, we know that's a real number. Let's go to our next coefficient, which is pi. Now, pi is an irrational number, which irrationals are real. So that means we also, even though pi seems weird to be a coefficient, that is a real number. So that also checks off. That means that this function is a polynomial. So I'm going to write yes for indicating it is. So our next step is we have to write it in standard form. So once again, we have g of x equals. Now remember, we start from the biggest exponent. So we look, it seems like pi x squared would be our biggest. So we start there. So we go pi x squared, because the 2 is the largest exponent. Then we go to the next one, which is degree of 1. So that'll be plus 7x. And then our last thing should always be the constant, if there is one. So that'll be minus square root of 3. Okay, now that we've written in standard form, we got to figure out the degree. So that means we just look at the biggest exponent, or the largest. And if we look, it looks like 2 is our largest exponent. Now, going off of the degree, we have to figure out what type of function this is, more specifically. So if you need to go back to that chart, we're going to go down to degree 2, and that was our quadratic. Now, you guys should remember that because we just finished that unit. So that is a quadratic. Okay, last one is we have a leading coefficient. So we need to talk about what that is. Remember, that is the value in front of our first term. And that coefficient is going to be pi. So we write that. Okay, so now that we've done some examples together, I would like you guys to go ahead and do C and D. So you're going to do the same thing. You're going to figure out if the function is a polynomial. If it is, you're going to write it in standard form and then determine the degree, the type, and what the leading coefficient. Now, if it is not a polynomial, all you have to do is just say no. So I'm going to go ahead and pause the video and try to do C and D on your own. Okay, so hopefully you pause the video to figure out C and D. So let's kind of go over this. So first thing is we have to make sure that our exponents are whole numbers. Okay, let's start on our first term here. We have 2 as our exponent. Well, 2 is a whole number. Now let's look at our next term. We have to the negative first. Now remember, whole numbers are the positive side of our integer. So that's 1, 2, 3, 4, 5, 6, and etc. Since negative 1 is not a whole number, that means this function is not a polynomial. So we can just automatically say no, because this exponent is not a whole number. Okay, let's go ahead and try D. So we're going to do the same thing. To figure out, we have to first determine if the exponents are whole numbers. Well, on our first term, x to the first, right? Well, 1 is a whole number, so that works. Now, let's look at 2 to the x. Well, notice here that x is in our exponent spot. It's not even a value. It's a variable. So that means because our exponent here is not a real number, it's a variable, once again, we'll say no. This is not a polynomial. Okay, so let's go ahead. We're going to get to our next slide. So now that we have identified what polynomials or what functions are polynomials, okay, we are going to now evaluate. The first way is to do direct substitution. Now this shouldn't be too hard because you've done this numerous times. So for this one, we have f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8 when x equals 3. Basically, when we do the direct substitution, all you're doing is finding the corresponding y value to your x. So we're going to take our 3 and plug it for every place we see x. So here we have f of 3. So I plug 3 into here just to represent that's my x value that I'm plugging into my function. 2 times 3 to the fourth minus 5 times 3 to the third minus 4 times 3 plus 8. There we go. Now I would advise, make sure you know how to do this without a calculator, so try without a calculator. And then if you ever need to double check your answers to make sure you're correct, that's when you can use your calculator. So remember, whenever we're doing this, we do our exponents first. We do 3 to the 4th power first. That gives us 81. So we have 2 times 81. Minus 5 times, we now do 3 to the 3rd power. That gives us 27. So negative 5 times 27. We can evaluate negative 4 times 3. That gives us minus 12. And then we get the plus 8. So now I'm just going to multiply my 2 and 81, and then negative 5 and 27. So I get 162 minus 135 minus 12 plus 8. Now, if you had to do this without a calculator, we would not give you very large numbers, but make sure you do know how to calculate something like this without a calculator. So now we just combine like terms. So meaning that f of 3, so when we plug that into our function, our final answer or corresponding y value is going to be 23. And this will be our final answer. So I said before, this shouldn't look too different. You've done it multiple times throughout numerous years of math. All you're doing is just plugging your x value into the function to get your y. Okay, now let's try a new method, which you guys probably have not seen before. It's what we call the synthetic substitution. Now, in this case, we're going to probably get the same answer because we have the same function and the same x value. But instead of plugging in these values directly into the function, we're going to make a chart to find our following y value. So what I do first is I put my 3, which is the x value. I'm going to put a box around it just to indicate that's my x. Now my next step is to use the coefficients from my polynomial function. So I'm just going to write down each of these coefficients. So we start off with x to the 4th, and that coefficient is 2. So I'm going to write 2. Now we want to make sure we're going in descending order. We should be x to the 3rd. And that coefficient is negative 5. Make sure if there's ever a subtraction sign or a negative that you include that. So we have negative 5. Now notice, once we go from negative 5x third to minus 4x, we're actually missing a term. We are missing the x squared term. So whenever you are missing a term or terms, we actually have to use a placeholder there. So what we're going to use is use 0 as our placeholder. So instead of writing negative 4, we have to put 0 to show that that is the coefficient of our x squared term. Now that we put our placeholder there of 0, now we go to our next exponent. Okay, so x to the 1st, and that coefficient is negative 4. Then we go to our constant, which is 8. Now, once you've written all the coefficients of each of your terms here, leave some room, and we're going to draw a line. Now, our first thing that we're going to do is just bring the 2 down below this line. Now, every single number that is below the line, we are going to multiply it by 3. So here we do 3 times 2. That should give us 6. Any number that you get the product of, we're going to put it above the line. And then we're going to add the values. So we do negative 5 plus 6. That just gives us 1. So 1 is below our line, so we multiply it once again by 3. So we do 3 times 1 to give us 3. So whenever you find the product, bring it back above the line and add the 2 numbers. So we do 0 plus 3 to give us another 3. Then once again we do 3 times 3, that gives us 9. Once again we bring that product up above the line and add it to the negative 4. So we do negative 4 plus 9, that gives us 5. And then we do 3 times 5 to give us 15. That 15 will go above the line, and once again we're adding. So we do 8 plus 15, and we get 23. Now in this case, you should get a number at the end. This is what we would call our remainder. And our remainder is our final answer. Now, make sure you understand how to do the synthetic substitution, because this synthetic way is going to come back later on when we actually divide polynomials. So make sure you understand how to do it now, so then when we come back to it, it's a lot easier to understand it. So your remainder is your final answer. So you can just box your remainder if you want to, or to make it a little bit easier for me, like if I have to grade, you can rewrite it as, and I'll do this in blue, so f of 3, so indicating that, oh, when our x value was 3, our corresponding y value was 23. And this could be also written as your final answer. Okay, so make sure that you work on the homework. It is 2.21. It is on Schoology. If you have any further questions, make sure you email me, okay? Or make sure that you can go to any math teacher along the hallway to get help with any of this information.